10.2, page 170 onwards, deals with substitution. In other words, you take numbers and you plug them into a given formula, or even a formula you have to create yourself, and then get an answer. Here's a starter question, question 4 on page 170. Question 4 then. Okay, says Jane is using the formula V equals U plus AT in science. Not anymore, I don't think. She's told that U is 12, so you put a 12 in there where U is. A is 9.8, so you put a 9.8 where the A is, and we're told that T is 15. Don't worry about what it actually means, it's a real formula, it's really good. Find the value of V. Right, what does that mean? V equals 12 plus 9.8 multiplied by 15. I mean, I prefer to use brackets than timeses, even with numbers. Now I'm allowed to use a calculator, so because it's unit 3, that's 12. 9.8, multiply that by 15. That gives me 147. Now pick up the machine and add 12. Answer 159, and it's probably going to be meters per second. I just happen to say that's true. Right, 149 meters per second, 159 meters per second, 159 is good enough. Alrighty then. Right, that's that one. I'll do a bit of question 5. Question 5 says, Kareem is working on polygons in maths. He has a formula. Here's the formula. He's got T equals 180. Some of you might recognise this. Bracket 2, bracket n minus 2. He uses the formula to find the sum, T, of the interior angles of a polygon with n sides. So, I don't know. Let's have a look. There's your pentagon, for example. We have n is 5, 5 sides, and T is the total interior angles. These 5 angles added up. Alright, got the idea, so I put a big T in there. That'll be fine. So Kareem wants to use the formula to find the sum of the interior angles of a polygon with 4 sides. Okay, so you plug a 4 into there. Here I go. T equals 180 degrees multiplied by 4, take away 2. Please don't multiply at the bracket, it's not necessary. We've got real numbers there. That means 180 times, well, 4 take away 2 is 2. So total number of degrees for the interior angles of a 4-sided shape is 360 degrees. Very easy. 9-sided shape, work down here. T equals 180, bracket n minus 2. This time we're going to stick 9 sides in there. Here I go, 180 bracket 9 minus 2. What does that mean? It means 180 times, well, 9 minus 2 is 7, so I can get 7 triangles out of this 9-sided shape. That's what that means. Pick up my machine. 180 times 7. Here we go. 1,260 degrees. Yeah, seriously, do you remember? Look, I take this hexagon, for example, and I break it up into 1, 2, 3, 4, pentagon. So here's a hexagon. Say, I break it up into 1 triangle, 2 triangles, 3 triangles, 4 triangles. Remember, each of these is 180 degrees. It's just a little bit of revision. We've done this in a previous chapter. As you can see, 4 times 180 is going to be 720 degrees, because I just happen to know that one anyway. So there you go. Don't get fixed onto having all the interior angles being only 360. As soon as we increase those number of sides to 5, 6, 7, 8, etc., the number of angles inside the shape increases. They become more and more obtuse, and therefore the sum of all the interior angles becomes greater. Alright, so there we go. So 9 take away 2, 7. I've got 7 triangles in this 9-sided shape, like I've got 4 triangles in this 6-sided shape. Comes to 1,260. Then he wants me to work backwards. I want to use his formula to work out the number of sides of a polygon when T is 1,440 degrees. Okay, 1,440 degrees. So sum the interior angles. 180 times something, take away 2. First step, take the 180 next door and divide. So n minus 2 is going to be 1440. Gone glitchy. 1440 divided by 180. May as well cancel some zeros and get something right. Right, 144 divided by 18 comes to 8. Great, lovely. So I've got n, take away 2 is 8. So take the minus 2 over and add. N equals 8 plus 2. Guess what? It's a 10-sided shape. Decagon. Alright, bit of revision there. Decagon. And can't be bothered to do the other one. Incidentally, it's 720 degrees. I just happen to have worked it out over here. It's this hexagon over here. Alright, hexagon, six-sided shape, and they actually asked that in question 5b part 2. So that's that. Turning over the page when it wants to. We've got a formula. This is Max. It's doing degrees centigrade and degrees Fahrenheit. So question 6, I've got Fahrenheit equals 1.8 C, which means 1.8 times C. Then you add on the extra 32 degrees in Fahrenheit. Right, it changes temperature from degrees C to degrees F. Use the formula to change the following from degrees C to degrees F. And the first one is 10 degrees C. Well, let's put it in there, shall we? So what's the Fahrenheit one going to be? 1.8 times 10. Again, I'd rather use a bracket there, plus 32. That's going to give me, well, that's easy. That's going to be 18 plus 32. Don't need a calculator for that. Had that little bit of rubbish get there. Right, what we've got here, 50. So it's 50 degrees F. That's that one. If I want to use minus 3, quote the formula, 1.8 times minus 3, and then add on the 32 again. I know 3/18s are 54, so it's going to be minus 5.4, then add on 32. Now I don't want to get this wrong on my video, so it's going to be minus 5.4, add on the 32, comes to positive, it would be positive, 26.6 degrees F. Okay then, or just F. And then we've got to work backwards, so this is part B, I won't do them all. Use the formula to change the following from F's into C's. Okay, great. So I've got 52 degrees F. So here I go. I've got 52 degrees F must equal 1.8 times C plus the 32. Again, take the 32 over and subtract. So 1.8 C equals 52, take away 32. Well, that's 1.8 C's equals 20. So degrees C is going to be 20. Take it over and divide. Perform the inverse operation and do it. So 20 divided by 1.8, that comes to 11.1 degrees C, and of course it's recurring, so let's put it in there. So 11.1 recurring degrees C. So 52 degrees F is about 11.1 degrees C. Okay, that's that done. I think I'll do one more of those. 23 degrees F. So here I go, put it down here. I've got 23 degrees Fahrenheit, 1.8 times C plus 32. I've still got to subtract my 32 on the other side. So 1.8 C equals 23, take away 32. Don't worry that it goes negative, it does get jolly cold. So try to understand that. So 23 take away 32 comes to negative 9 degrees, that's cold. So in degrees C we go minus 9 divided by 1.8, and that's going to give me, bam, minus 5 degrees. Okay, so minus 5 degrees C is the same as 23 degrees F. Yeah, it's true. Very good. Cancel that for now. Right, question 7, note 2 similar. Question 8, oh, it looks too basic really, but let's just do it quickly and move on. Right, Susan uses the formula, this is Susan, P equals 2L plus 2W. Why is she using that? To find the perimeter of rectangles. Ah, right. So that must be like the length, that must be like the width, alright? And there's a length over there because they're rectangles, and you must have another width over there. Right, got the picture. Right, so Susan has a rectangle with L equals 5 and W equals 4. Right, so that equals 5, plug it in, and W equals 4. Very good. Oh, centimetres. Find P. I can do that. So P equals 2 lots of the length, in other words 2 times 5, and 2 lots of the width, 2 times 4. What have I got? 10 plus 8, all together now. 18 centimetre perimeter. I mean, add it up honestly, so what have I got here? 5 plus 5 is 10, 4 plus 4 is 8, 18, it works, doesn't it? Right, Susan has a rectangle with P is 97. Okay then, let's just do this over here. So if I write down here P equals 97 centimetres, she measures L to be 28.4. Okay, 28.4 is there. This must also be 28.4. Work out W, in other words the width. Very good. Alright, plug it into the formula. I've got P equals 2L's plus 2W's. So I know 2 times the length of 28.4 plus 2 lots of the width come to 97. Work out this little bit with the machine. 28.4 times 2, 56.8. So 56.8 plus 2 lots of the width come to 97. You know, take it over, subtract. 2 lots of width equal 97, take away 56.8, and that will give us, on my machine that says 40.2, and therefore the single width will be 40.2. You know what to do, divide by 2, that comes to 20, ooh, wasn't watching, that comes to 20.1, and there it is, 20.1 centimetre width. Alright, that's that one done. And I really fancy question 9 because we can get a throwback to rules on sequences, and I'll draw the picture and then try and get this finished. Right, I'll draw you what I've got in crude form. Fences are made up from identical lengths of wood as shown. Anyway, I won't draw it brilliantly, but essentially I've got that, that, that and that, okay? So I've got 4 bits of wood to make fence of size 1. Now fence of size 2 is going to be more of a pain, so let's try and speed this up a little bit. Oops, that goes like that. I mean, it's great drawing it freehand, it really is a lot of fun. You can see where this is going, can you? Right, and that's called size 2. I don't want to draw anymore, I really don't. How many pieces of wood are needed to make size 3? Oh grief, okay, let's just do it then. So this is size 3, so one of these, 2 little blocks across, then a straight bit, then 2 little blocks across, and then a straight bit, and then 2 little blocks across, and then a straight bit. There, I've done it. Right, how many have we got here? Let's just do some sums. Size 1, 1, 2, 3, 4 bits of wood. I can do that. Size 2, 1, 2, 3, 4, 5, 6, 7 bits of wood. I can do that. Size 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bits of wood. I can see a sequence. Right, what have I got here? How many pieces of wood are needed to make size 3 fence? Our answer, 10 bits of wood. Done. Write a formula, here it is, for the number of pieces of wood that are needed for a fence of any size. In other words, the nth term. Now look, do you remember this? Let's just take on a green here. From 4 to 7 we go plus 3. From 7 to 10 we go plus 3. So straight away I know it's a 3n rule. Now do you remember this? Get the 0 term. What number plus 3 makes 4? Answer 1. Okay, because 1 plus 3 makes 4. So the rule is 3n plus 1. Put that in a blue box and sign it off as good. Okay, that symbol means it's good. Next bit, use your formula, there it is, to find the number of bits of wood required to make fence size 8. Now honestly, I'm not going to draw all these, you know, and go up to size 8. I've got a formula now. In other words, substitute n equals 8. So in other words, fence number 8, the 8th member of the family. Let's do the maths. I've got 3 lots of 8 plus 1. What's that? 24 plus 1, 25. So without having to draw the picture and count all these little bits of wood, I know it's 3 times the fence number plus 1. 25 bits of wood for the 8th size. D says, use your formula to find the size of a fence containing 37 bits of wood. So we create a formula. So I know 3n plus 1 is the expression for the nth term, but I'm told this will come to 37 bits of wood. So I've got a very, very simple equation. Take the 1 over and subtract. 3n equals 36. Take the 3 over and divide. 36 divided by 3, 12. So with 37 bits of wood, I can make a fence of size 12, a size 12 fence. Alright? Now, this is E. This is question 9, by the way, on page 171. Jake says that his garden is very long. Well done him. So he needs a fence with 101 pieces of wood. Explain why Jake cannot be correct. Well, let's try solving a formula with 101 bits of wood. Okay, 101. There's the formula. We can take the 1 away, can't we? Sure we can. So 3n equals 100. Now, so fence size n will be 100 divided by 3, which is 33 1.3 recurring. Well, that makes mathematical sense, doesn't it? The trouble is, you can't have 33 and a third of a fence. You either have fence size 33 or fence size 34. There's nothing in between. So we can say this is not a whole number, therefore Jake is wrong. This is not a whole number. Let's just say it. Not a whole number. So therefore Jake is wrong. I'll stop there because that's the last question. That goes up to grade D only, and I'm going to see you soon.